Today we're going to be going over Monte Carlo simulations and how you can use it in finance. First, I will be explaining the concept of what Monte Carlo is. Then I will be going over a code that estimates the stock price over a certain number of days. I will be writing the code in Jupyter Notebook, and if you don't have that installed, you can use the Google Collab link which I have provided in the description below. Google Collab is free and there is no setup required, so you can get started immediately. At the end of the video, I also have a very fun experiment planned. I basically ran the same code last week and tried to estimate the Google closing price for 2 days later. And in this video, we're going to be comparing the results to the actual closing price of Google. If you're unfamiliar with the concept of Monte Carlo, let me try to explain it as simply as possible. Monte Carlo gets its name from a gambling location in Monaco, and it's a type of simulation that evolves randomly. By using random sampling and statistical modeling, you can estimate the probability of different outcomes. So how does this actually work? Let's say you woke up late for work and you want to know the chances of you making it in time. So the first step you do is identify the problem, which we just did. Then you will identify all the variables, that is the amount of traffic or the weather conditions, everything that might impact your commute to work. Then we will choose a statistical distribution. This distribution is specific to your task, so you must choose it carefully. There are a number of different distributions that you can deploy. Some of them are log normal distribution, fat tail distribution, etc. After we've identified all these variables and what distribution we have to use, then we run the simulation for thousands or even millions of times. The more simulations you run, the more accurate your result will be. This is according to the law of large numbers. But sometimes you might be held back by your system, so don't worry about that unless you're doing it in a professional sense. After we have generated all the simulations, we can use percentages or percentile to find the probability of us making it to work. So let's say we ran a simulation and try to estimate the chances of us making it to work, and it could come out to 10% because you just spent 30 minutes trying to figure out if you're going to make it to work in time. So Monte Carlo has a variety of different use cases. You can use it in your day-to-day life or use it in finance for more complicated problems. Now let's jump into the coding bit. So the first thing that you will have to do is import all the dependencies. If you haven't done already, just click on the Google Colab link or download the Jupyter Notebook from the description below. If you're in Google Colab, you might want to run this command because you probably don't have some of these dependencies. So if you just run this code, I'm not going to run it because I already have everything installed. But if you run this code, then everything you need will be there. Then the second thing you want to do is choose the stock price you want to simulate and select the start date. So for this video, I will just choose the Apple stock price and I will choose the start date to be 2020. Then we're just going to run that to save all the variables. Next is our function to import stock data. We're going to be using Yahoo Finance. I have this function definition that imports stock data, and the inputs that you take is the ticker symbol and the start date. So the first step would be to define the data frame. So we're just going to name it data. And then we're going to use Yahoo Finance to get the stock data. Then we're going to store everything inside a data frame. If you want to define a set end date as well, you can do that by just doing end and choosing your end date, but For this video, I'm not going to be adding that variable. After we've done all these things, then we're just going to return the data variable and run the function. Then we're just going to plot the closing price. I wrote this down beforehand, but just to go over it quickly, this sets the size for your plot. Then you choose your x-axis and your y-axis. You can choose the title and then the labels, the x and y labels, and all these are just for making it more visually appealing. I'm gonna run it. Okay, perfect. So then we have the closing price for Apple, as we can see, from 2020 to today, or maybe yesterday, I guess. Now let's go over the functions. We're gonna be using log normal distributions. So for the first thing we have to do is calculate the log returns. I just wrote down a few things as to why you want to use log returns over mean returns. I can go over this in another video if you want, but let's calculate the log returns. I have this function that takes in the stock data and uses the closing price to get the log returns. A lot of people use adjusted closing prices, but for today we're just going to be using the closing price of Apple. So log returns is equal to np.log. Then we're just gonna put a stock data with the closing price. So I chose +1 because it converts the data into a suitable format for log calculation. PCT/change calculates the percentage change between the current and the prior element in the closed series. Now after we calculate the log returns, we're just gonna do this because the log returns for day 1 is a null value since you're not comparing it to anything beforehand. Then we're just gonna plot the log returns, but I forgot to return. You can see the log returns. If you don't understand this graph, don't worry, I don't either, but it just looks cool. Next thing we're going to do is calculate the volatility. This is a very simple calculation, and we're going to take the input as the log returns. Volatility of a market is basically the standard distribution. If you did not know that already, we're gonna return volatility and then just run the code to test if we are getting a result, and we do. So the next thing we're gonna do is run the simulations. First, we select our variables. The first variable we select is the number of simulations. Define a variable number of simulations is equal to, you can do 1000, 10,000, 100,000, a million, but the more zeros you add, the longer it takes to run. So for just this video's sake, I'm going to do 1000, and then you can choose a number of days. This can be 1 day later or it can be 100 days later as well. It just depends on what you want. Then the last thing we're going to do is just get the last price or the last closing price in our data. So if you did not define an end date, that would be yesterday's closing price. Actually, use now we're going to define a simulation function. So the input variables are the number of simulations, the number of days, the last closing price, and the log returns. The first thing we're going to do is calculate the daily volatility. So daily volatility is equal to, use our volatility function. Then we're going to initialize a list to store all the simulation results. We're just going to name it all simulations. Then we're going to run a loop for X amount of times. Define a price series variable. The price series variable basically just makes a new list with the last price as its first variable. It'll make sense later, so don't worry about it. Then we're gonna go over the number of days you want to simulate. So for this example, this is going to run 100 times. Then we're gonna define a price variable. This is the log normal distribution that I talked about. This calculation basically uses a random value from the log normal distribution, and basically using the standard deviation, we try to estimate the stock price randomly. Since we have the price generated, we're going to use price series list and add a value to it. We're going to add it to our main list. Then you can just create a data frame to store all the results. And we're going to return this. No errors. Let's just run it to see. Okay. If you are confused about how it works, basically this is the closing price for the last day in a data frame. As you can see, it is always the first variable in every simulation. Then from this price, we use the price series here. From this price, we estimate the price for the next day, and then we append it to the list, to this list. As this gets added, the loop will run again, and it's now going to estimate the stock price using this number instead of this number, and it keeps going on till 100 days. It's not listed here because I just printed out the head, but it keeps going on. Each simulation has a different result. This is because, again, the calculations are done randomly, and this is why the more simulations you run, the more accurate your estimation will be. Then we're just going to plot the Monte Carlo simulation. This might take a long time if you have like 10,000 simulations, but for 1,000 it does it quite fast. We start from the same closing price, and then it basically randomly comes up to a certain value. Some of the results are on the extreme end. So if you want to calculate the estimated price for Apple for 100 days later, I will show you how to do it using the live testing that I did. So I ran the Google stock simulation and simulated the price 2 days later. So the date I ran it on was 27th, and I estimated the price for the 1st of March. Basically, I ran the code and extracted the prices for the end of the second day. Since we ran this for 100 days right now, it's going to give us all the values at the end of this graph. Then you just basically get the mean of all that data and you get the expected price. You can also calculate the interval that the stock price is going to be between. And if I run this code right now, it's going to give me a different value. So I just saved the result from before. And the expected price that I got was 138.099 and the interval was between this. Now this is the same code but with a 98% confidence interval. Remember, the more confident you are, the larger the interval is going to be. The expected price was 138. This is our confidence intervals. And let's just check what the closing price for Google was. Google stock. Yes, you can track my location if you don't do that already. Now, as we can see, the closing price was 138.08. We weren't that far off at all. This is not financial advice and this might not work most of the time. So if you want to replicate the results for this video in any other problem that you want, you can do it easily by using the steps that I listed at the start of the video. You choose the problem, you break down the problem. The problem was to estimate the stock price. So you break down the problem and you first get all the data that you need. Then you choose your distribution and the variables that you want. So over here, the variables that I wanted was just the closing price for the stock. Then I also chose the distribution that I will be using, which was log normal distribution. So naturally I took the log returns for that stock. Then I calculate the volatility because that is what determines how the market is going to move. And the third step is to choose the number of simulations. And basically you just run a code that might look similar to this. And yeah, you can experiment with this as much as you want. You can try changing things around. You can try using different distributions for different problems. But just try to have fun with it. Now, if you enjoyed this video and found it useful, definitely leave a like and subscribe. And if you have any comments or if you have any questions about the code, let me know in the comments down below.